Now members, let us see how some questions are going to be. They will tell you that we are going to see some examples, this and this. Given that this one means that x is a normal distribution with mean mu and variance 2.89. Why? Because we know that if it's normally distributed, it's always like this with mean mu, then variance there. Always, this means that this is our mu and our variance is there. So meaning we need to, now we are telling us a find probability of x. Now we say that if we are in normal distribution, we always first standardize this and we convert it to z so that we can read its probability from the table. But before that, we need always to get the mu and then the variance. But how do we standardize? You know that standardize this, we always use the formula minus mu over sigma. So now, from here we can compare. From here we can compare is that our mu is 2. Then this one is equaling to 2.89. And now you need this sigma here. But to start here, sigma squared, this is the same as 1.7 squared. So your sigma is going to be 1.7. So after adding that, now you need to get the z here so that you can read it from the table. So you substitute your x. Your x now, this is what we take as our x. So to get z, we shall say this is going to be now our x, which is now 0. Then minus mu, our mu is 2. Then we divide it by our 1.7. And so our z here is going to give us, so there we have negative 2 divided by 1.7. So here we get negative 1.176. Now, these ones, when we are having the value of z, you always give it to 3 decimal places. Why? Because a table can only read it up to 3 decimal places. So, meaning that now, get this probability, now our z is here. So now we come and get our probability of z. So now this was less, so we need z less than, now this value, negative 1.176. Now this one, we said, now, we said it's greater. So it's going to be, you draw so that you can easily read it properly. So if I draw this, this is negative, it's this side. So if this is 0, then negative is going to be here, 1.76. So I need this probability here. And we said if you have this, it's the same as, so using this table, to start this will be the same as, now we shall get 0.5, then minus probability of now when we subtract of this, and then we take its modulus, which is negative 1.176. And so this would be 0.5, now minus the probability of 0 less z less 1.176. Now we read off this from the table. So how we read it from the table? You see we have 1.1. So you see our 1.1 there. So our z is 1.176. So now if I come to 1.1, I think we see 1.1. We read them in the cumulative. So 1.1 is here. It's under 7. So we move under 7. So this is under 7 here. Under 7. This is now 0.379. So if it's sloping, you always be careful. Now this one, you see, this one was sloping like this. So even this one is sloping like this. So this one will be the value 3790. But now we are under 6. So we know what are we going to add on under 6? We are adding a 12. So this value now, you get this 12 here. You add this to this value here. So now there we shall be having this as 0.5, then minus. When we read that probability, let me first make some additions there. We add 3790. Then we added on. We were adding get 2, 0.183. This one is 0.3802. And then when you subtract that, you get your curve and subtract that. So this is 0.5 minus 0.8. So there is a 2 there, 3802. And the answer I'm getting is 0.1198. When I told you you can just get this from a calculator, I told you, you press, this is how you press it if you have get the calculator. You press this mod, then after it brings the SD, then you press 1. Then after bringing the SD, you press shift, then you press this 3 here. It will give you now. Now the value there we have for Z is the Q. Now you press 2. And you press that 2, it will bring this to that. Then you press in the other value 1.176, then you cross. I think this is the value we have there, is what we have. This value here. So we come now to this part B. Part B, where we want the probability of x greater than 3. So can you standardize this? So here our Z will be now the x. This is the formula we're using. 3 minus 2 over 1.7. And so this Z will give me here 1 divided by, it's giving me, we give it 3 decimal places, 8. So now this Z, the sign, it follows that sign greater than. Now this x is giving us this value of Z, 0.588. And what happened there? Say if you approach this on this curve, this one will give you the interpretation. So see, this is the value, this is 0, this is positive, so it's here 0.588. So you need this value greater. So what we say that you get the whole of this is 0.5, so you get this will be the same as 0.5 minus, if you get the probability from here to here, so the probability of Z 0.588. Then this will be 0.5. Then reading off the table, read off the table there. The value we are getting after reading off the table there is 0.2217. You give it to this one, they are 4 decimal places. So 0.5 minus 0.2217, the answer there is 0.2783. Now when you come to this, so that's how we handle this too. When you come to this, this is, now you said this one is modulus. How do we handle the modulus? We first need this x here. So if this is our x, so in my part A, first of all I first make this x the subject. So probability of modulus 100 less 18. We say this is the same as probability. Now this will be negative 18 less x minus this 100 less 18. Then we make x the sum to protect this side. Shall be having probability of now negative 18. Now when this comes inside, we add 100 less x less 18 plus 100 there. So now this will give us probability. This one minus 100, we get 82 less x less 118. Now after that, now this is x. Now you convert this to z. Convert them to z. This will be now equaling to, now our probability of 82 less x less 118 will be, now we convert this directly to z. So this will give us the probability, convert them to z, you get the value of x there. You subtract off now, let us get our mean. From here, you can see that this is following a normal distribution. So let me start with that. So this is what they gave us was x was following a normal distribution. This is now our mean, and then sigma squared. So here we have x following the normal. Here they are giving us 100, then they are giving this as 81. So meaning that from there, our mu is 100, then our sigma squared is 81, which will be, we need this value, which is 9 squared. So it's that our sigma is going to be 9. So now, from here, my probability, this one now, 82 less x less 118 will be, what we do, we just convert now this, we standardize this x by using this formula here. So you get this x value, the same as, you get this x value minus the mean, our mean is 100, divided by the sigma, which is 9, less, now this will become z, less this value of x, then minus mu, which is 100, divided by our 9. And so this would be the probability of, this would be negative 2 less z less 2. And we said if we have this, this is as simple as, now you can see that when I try to put this on this graph, it's going to be like this on the norm. This is our 0, so I have my negative 2 there and my 2 there. So between this is the probability we are looking for. And we said the numerator and this and this are the same. So this one we say it's the same as 2. Okay. We said it's the same as 2. The probability of 0 less z less 2. Then you read off that from the table, and you can read off this times I'm getting 0.0473, and then multiply this. I'm getting 0.954 and then 6. That will be our answer there. So what happens to this? The same idea. This one, now this one is a bit different. So use the same idea when we are handling that number there. So when I come now to this was part A. When I come now to part B, they are giving me probability of modulus of minus 100 greater than 5. What do we say? So this one is greater. You can't interpret it like, if it's less, you interpret the way we have interpreted this. But this one is not, so this one is the same as 1 minus probability of this modulus now, x minus 100. Now this one changes to, and this equal to sine. Then we first interpret this. So that will be, this will be now 1 minus the probability. This will be now negative 5. Then we shall add on 100 less x less 5 plus 100. I'm skipping some steps there. These steps here. We take this and so on. So this will be now 1 minus probability. This is going to give us 95 less x less. All of this is going to be 105. So what happens there? This will be now 1 minus the probability. Now we standardize this. We get this x minus the mean. Our mean was 100 over 9. Let's now, this one becomes z. The moment we do this, now this becomes z. 105 minus 100, the whole over mean. And this would be 1 minus the probability of. Now, here we have this as 95 divided by negative 5 divided by 9. We get negative 0.556 less z less. There we have a 5, which will be 0.556 to 3 decimal places. So this would be now 1 minus 2 probability of now 0 less z less 0.556 5, 6y, because you see they are the same. And when you press that, when you read that from the table, you can easily see that that one is going to be. Then if you multiply it by 2, okay, this will be 1 minus 2 into 0.2109. And so the answer will give us there 2 times so you shall get there 0.578 and 2, and that will be our answer. So I think members now you can clearly handle this. You take this side and you take the other one the other side. So that's how we handle the first examples. We are going to see more. I wish